Hello everyone, I am Adriana Fernandez and today let's talk about semiconductors, the tiny materials powering our modern world from mobile phones to electric vehicles and so much more. As technology evolves, so does the need for better semiconductors. That's where silicon carbide and gallium nitride come in, pushing beyond the limits of traditional silicon and unlocking new possibilities. So, how can the new semiconductors affect the development of more sophisticated computers? So, first, let's start by looking at computers with materials like silicon carbide and gallium nitride. We are seeing a huge leap in performance. These materials can handle higher voltages, larger currents, and hotter temperatures, which allows us to design faster and more efficient computers. So, this isn't just about the speed, it also enables us to make computers smaller and more compact while delivering more power. So, another benefit is the energy efficiency. Using these new materials helps reduce power consumption, which is important in data centers and high performance computing. So whether it's for personal laptops or large scale servers, silicon carbide and gallium nitride are setting the stage for a new era of sophisticated computers. So what is the impact of the new technology to electric vehicles and automations? So now let's talk about electric vehicles or EVs, and automation systems. One of the biggest challenges for electric vehicles is balancing battery life and range. So silicon carbide helps here because it is super efficient at converting energy, allowing vehicles to travel farther on a single charge. So, as mentioned earlier, uh, it allows vehicles to travel farther on a single charge. So, this reduced charging time. With gallium nitride, electric vehicles chargers uh, can handle power faster, so you s- you spend less time waiting for a full charge. Another advantage is durability. These materials are tough enough to handle high temperature and voltages, which means they last longer and perform over time. So, enhanced automation system, then it comes to automation, especially is in our industry that rely on precise control. Silicon carbide and gallium nitride are making systems faster and more reliable. This means factories can run smoother, robots can operate more accurately, and all of these translate for better efficiency. So, what is the advantage of the new semiconductor as compared to traditional one, to traditional semiconductor? Um, Compared to traditional silicon, as mentioned to our videos, these materials bring some serious advantages. So we have here first, higher temperature tolerance. Silicon carbide, for example, can handle temperature up to 300 degrees Celsius and beyond, maybe even 900 degrees, as mentioned in the video, with the right packaging. Compared to traditional silicon, it only limits around 175 degrees, so that this makes silicon carbide perfect to higher or high power applications where traditional materials might fail. Then there is greater efficiency. Both silicon and gallium nitride have much lower energy losses, which is crucial for devices that require high power. So for The design, it is much compact. Gallium nitride is especially useful in smaller electronics, allowing us to make products more compact. Finally, although silicon carbide and gallium nitride can be more expensive to produce, their efficiency and durability lead to cost savings over time, making them a worthwhile investment in many cases. For our last topic, what is the future of computer engineers in relation to the new semiconductor technology? So, what does this mean for the future of computer engineers like us? With these new semiconductor technologies, we have a world of opportunities opening up. There is a growing demand for engineers in the field like power electronics, electric vehicles, technology, and high frequency communications. Like mentioned in the video, the example of this is the 5G communication. So next, skill evolution. To make the most of these opportunities, we will need to learn more about this wide bandgap materials and how to work with them in real applications. Another exciting thing is that the chance of pioneer sustainable technologies. As the world shifts toward greener solutions, engineers using silicon carbide and gallium nitride will be at the forefront of creating more energy efficient systems. Innovation in manufacturing. Because these materials require new processing technologies, we have the chance to innovate in manufacturing as well. In conclusion, silicon carbide and gallium nitride are more than just new materials. They represent the future of semiconductors by offering high efficiency, the ability to handle extreme conditions, and applications in everything from electric vehicles to advanced computing. These materials are reshaping technology as we know it today. And for us future engineers, this means exciting possibilities to work on cutting edge projects and to drive forward innovations that make a real impact. As Albert Einstein once said, we cannot solve our problem with the same thinking we used when we created them. These new materials allow us to think differently and solve today's challenges in ways that we are not possible before. Thank you for watching, and I hope this video gives you a sense of just uh, how transformative these new semiconductors can be.